Okay, so now we're gonna look at scapulohumeral rhythm now that we've analyzed our resting posture of the scapula. So quick reminder, for active shoulder abduction, total range of motion is typically 180 degrees, that's normal. Now we know that the scapula contributes to part of that through upward rotation and that the glenohumeral joint contributes to part of that with abduction. So typically we expect about 60 degrees of upward rotation within that 180 degrees, and then 120 degrees of abduction at the shoulder. So when we think about sequencing of events, what we're looking for is the first 30 degrees of abduction should be coming just from the glenohumeral joint. Once we hit that 30-degree mark, there to the end of the 180 degrees is where that 2-to-1 ratio of scapula to glenohumeral motion comes into play. So let's go ahead and we're gonna watch this. So what we're gonna do is we're gonna ask John to abduct his arms at like a medium controlled pace, and we're gonna have him do it 5 times. So go ahead and start, John. The first thing we wanna see is, does he get that full 180 degrees of motion, yes or no? And if not, is one side different than the other? So for John, there's a slight decrease, I would say, on the right side compared to the left when I look at his total range of motion. So then the next question is this glenohumeral or is this scapular? So the first 30 degrees looks the same on both sides. It's once the scapula starts to kick in that we start to see differences side to side. Go ahead and do that again. So with the scapula, we should see smooth coordinated upward rotation and controlled coordinated downward rotation. Good. Let's have you face the side here. So you're gonna go ahead and abduct your arm again. When we look at it from the side, we should see that the scapula should hit about midline of the trunk when it hits all the way up for full upward rotation. With John, his scapula is just a little bit shy of midline. So for me, I hypothesize that the scapula is contributing to why there is a little bit of asymmetry side to side. Go ahead and face the back again. When he goes into upward rotation, go ahead and come back up again. He kind of sticks here a little bit and doesn't quite achieve it to the fullest extent like he does on this side. And then lower down nice and slow. On the way down, what we see is what we call scapular dyskinesis, which is poor timing or control of the scapula with downward rotation. And you can see that evidenced by almost like a shaking movement pattern as he comes back down. So we'll do this right here. Go ahead and come back down. So we start to get a little bit more of a shaking pattern there. You're good.